The universe, vast and mysterious, it stretches beyond our comprehension, a place where stars are born, live, and eventually die. And somewhere in the heart of it all lies the center of our galaxy, the Milky Way. A place humans have only dreamed of reaching, but what if that dream is no longer so distant? What if, in the year 2300, we've finally discovered a way to get there? This isn't just a dream anymore. Humanity has always looked up at the stars with wonder. We've explored the moon, sent probes to distant planets, and even established colonies on Mars. But now, we're setting our sights on something much, much farther. On a journey that will take us to the very heart of our galaxy. We didn't start this journey yesterday. The seeds were planted centuries ago in the minds of dreamers, explorers, and scientists who pushed the boundaries of what we thought was possible. From the earliest days of space travel, when the thought of landing on the moon seemed impossible, to the breakthroughs in faster-than-light technology, humanity's journey into the cosmos has been a tale of innovation, resilience, and ambition. And now, in the year 2300, we've achieved something that was once considered pure science fiction, a ship capable of traveling to the center of the galaxy. A journey that would take us across unimaginable distances, through uncharted territories into the unknown. But what drives us to take on such a monumental challenge? Maybe it's the need to understand our place in the universe. Maybe it's the urge to push the boundaries of human potential. Or perhaps it's just the unyielding curiosity that has fueled every great discovery throughout history. Whatever the reason, one thing is certain. We're about to embark on the greatest adventure humanity has ever known. But this journey isn't just about the destination. It's about the incredible challenges and discoveries along the way, the unknowns, the dangers, and the incredible wonders that lie ahead. The center of the galaxy is waiting, and the human spirit is more than ready to meet it head-on. This is our story, a journey to the very heart of the cosmos. A journey that begins in the year 2300. Humanity's thirst for exploration is nothing new. For centuries, we've looked up at the stars with a mix of wonder and ambition. From the first telescope to the earliest rockets, we've always pushed forward, driven by a desire to discover the unknown. But how did we get to this point where a journey to the galactic center is not just a dream but a reality? It all began in 1969 when humans first set foot on the moon. That small step for a man was, in many ways, a giant leap for mankind. The moon wasn't just another place to visit, it was a symbol of possibility. If we could land on the moon, what else could we do? Fast forward to the 21st century and we didn't stop there. We set our sights on Mars, establishing colonies and building a future beyond Earth. We developed technology that allowed us to explore planets, moons, and distant asteroids. Each mission was a step closer to the stars, but still the center of the galaxy felt impossibly far away. But even as we marveled at our progress, some brilliant minds were already thinking about what came next. While we were focused on our immediate solar system, researchers were dreaming of the stars beyond. They were focused on something that seemed utterly unachievable. The idea of traveling vast interstellar distances in a human lifetime. Then came the breakthrough we'd been waiting for, the discovery of faster-than-light travel. For decades, faster-than-light travel was a concept reserved for science fiction, but thanks to advances in quantum physics, propulsion technology, and a new understanding of wormholes, humanity was suddenly on the verge of something extraordinary. Scientists and engineers worked together, designing the technology that would allow us to break the limits of conventional travel. The breakthroughs came faster than expected, and by the late 22nd century, we were ready to launch our first interstellar mission. It was a bold move, but one that had been brewing for generations. That first mission was a success, marking the beginning of humanity's journey beyond our solar system. And with each mission that followed, our technology improved. We didn't just stop at reaching new star systems, we began to push for deeper, more ambitious goals. The idea of reaching the center of the galaxy started as a distant dream, but as technology advanced and humanity proved its ability to conquer the impossible, that dream became a reality. And in the year 2300, it was no longer just a fantasy, it was the next step in our evolution as a species. And so, the mission was set. A new generation of explorers, scientists, and dreamers were about to embark on the most ambitious voyage in human history. But it wasn't just about exploring new frontiers, it was about the next great chapter in our story, the next great leap into the unknown. So how exactly do we travel to the center of the galaxy? It's a question that's puzzled scientists for centuries. The distances between stars, let alone across an entire galaxy, are mind-boggling. Yet here we are in the year 2300 with the technology to make such a journey a reality. To understand how, we need to dive into the science of galactic travel, the breakthroughs that made it possible, and the incredible technologies that will carry us across unimaginable distances. At the core of our ability to travel across the galaxy is something called faster-than-light, or FTL travel. For a long time we thought this was purely theoretical, something that would never leave the pages of science fiction, but in the early 22nd century a discovery changed everything. Scientists found a way to manipulate space-time itself, allowing us to travel faster than light without violating the laws of This breakthrough, known as the warp drive, essentially creates a bubble of space-time around the ship. Inside this bubble, the ship doesn't actually move faster than light. Instead, the bubble moves, carrying the ship with it. By bending space-time itself, the ship can travel faster than light, making what once seemed impossible, well, possible. But it's not just about bending space-time. The propulsion systems needed to sustain such travel are equally extraordinary. Our ship, the Odyssey, is powered by a highly advanced fusion reactor, capable of generating the enormous energy required to warp space. It's the culmination of centuries of research into nuclear fusion, providing the perfect balance of power and efficiency to make long-range interstellar travel a reality. The Odyssey doesn't rely solely on one method of propulsion. The ship is equipped with multiple systems designed to keep it moving through the vast emptiness of space. The primary propulsion is, of course, the warp drive, but for more precise maneuvers, like navigating through star systems or avoiding gravitational anomalies, the ship uses a combination of ion thrusters and gravitational assist technology. Now, even though we've cracked the code for faster-than-light travel, there's still one major challenge: time. You see, as we approach the speed of light, strange things begin to happen. One of the most mind-bending effects is time dilation. The faster you move, the slower time passes relative to someone at rest. For the crew aboard the Odyssey, this means that while they'll experience time normally, time outside the ship, back on Earth for example, will pass much faster. A journey to the galactic center might take decades for the crew, but on Earth, hundreds of years could pass. It's a challenge we've had to overcome, and scientists have developed ways to mitigate these effects. Though not entirely. The Odyssey will be equipped with systems to help the crew maintain a healthy, synchronized timeline, but it's something they'll have to live with. Another major hurdle is the journey itself. The center of the galaxy isn't just far away. It's also filled with dangerous cosmic phenomena. Nebulae, black holes, intense radiation, and gravitational waves can all pose serious risks. To navigate safely, the Odyssey will be equipped with cutting-edge sensors and AI systems designed to detect and avoid these hazards. The journey won't be smooth sailing, and the crew will need all of their skills and technology to stay safe. Artificial intelligence, one of the most significant advancements of the 23rd century, plays a key role in ensuring the ship stays on course. The AI not only controls the ship's navigation, but also monitors the health and safety of the crew, analyzes environmental data, and makes real-time adjustments to the mission. In many ways, the AI is as much a member of the crew as any human. But even with all the technology, the journey will require the crew to rely on their own instincts and training. They'll face situations that no simulation can prepare them for, and it's up to them to adapt. The crew is made up of the best and brightest, not just in science and engineering but also in psychology, medicine, and even philosophy. After all, this isn't just a journey of technology, it's a journey of the human spirit. This is the science behind it, the physics, the technology, and the human determination that will carry us to the very heart of the galaxy. It's a combination of breakthroughs and bold ideas, and together, they've made this unimaginable mission possible. Living on the Odyssey isn't like anything we've experienced before. It's not just a ship, it's a self-contained world in itself. Designed for long-term space travel, the Odyssey has everything the crew needs to survive, work, and even thrive as they embark on this unimaginable journey. But life on board, over the course of decades, presents its own set of challenges. The first thing you'll notice about the Odyssey is its efficiency. Every inch of the ship is designed to maximize space, minimize waste, and ensure the crew's well-being. The crew's quarters are compact, yet fully equipped with everything they need, from sleeping pods to communication systems. No one has the luxury of a sprawling room or personal space like on Earth. But in deep space, that's just part of the deal. Aboard the ship, routines are everything. The crew follows a strict schedule of work, exercise, and recreation, ensuring they stay physically and mentally fit throughout the mission. Exercise is key, especially in zero gravity, to maintain muscle mass and bone density. And just like on Earth, meals are prepared in a communal dining hall, with synthetic food designed to provide all the necessary nutrients for long-term space travel. The ship is also home to some of the most advanced AI and robotic systems in existence. Robots handle routine tasks, maintenance, repairs, even cleaning, allowing the crew to focus on more critical work, like scientific research, navigation, and medical care. But these robots don't replace humans, they're there to assist, not replace. And the crew knows they'll be relying on each other, not just the machines, to get through the challenges ahead. Healthcare is another crucial aspect of life aboard the Odyssey. With no hospital or doctor just a few miles away, the crew's medical team is responsible for everything from routine checkups to handling serious emergencies. They've been trained to deal with everything, from basic injuries to the psychological toll of long-term isolation. The mental health of the crew is just as important as their physical well-being, and a support network is in place to ensure everyone stays focused and calm. Psychological support is critical on a journey like this. After all, living on a spaceship for decades is no small feat. The isolation, the constant proximity to others, the lack of natural sunlight, all of it can wear on a person. That's why the Odyssey has an onboard psychologist, whose job is to check in with the crew regularly, ensuring they stay mentally and emotionally healthy throughout the mission. Despite the challenges, the Odyssey isn't all work and no play. The ship has a fully equipped recreation area where the crew can unwind. Movies, games, even simulated nature environments. It's all there, designed to give the crew a much-needed break from the daily grind. For many, this is a lifeline, an opportunity to reconnect with something familiar and human. After all, it's important to stay grounded even when you're traveling to the stars. For moments of real escape, the ship has a virtual reality system that allows the crew to experience places they may never see again in person. Whether it's walking through the forests of Earth or exploring distant, uncharted worlds, VR gives the crew the chance to experience a piece of home or even experience new worlds without ever leaving the ship. And of course, leadership is crucial. The captain and senior officers are responsible for making the big decisions, navigating the ship, managing resources, and ensuring the crew stays on track. The captain is more than just the leader, they're the heart of the crew, making sure that everyone stays motivated, focused, and united in the mission's goal. The crew doesn't just live together, they work together. It's this sense of camaraderie that keeps everyone moving forward, even when the journey seems endless. They know that each of them has an important role to play, whether they're pilots, engineers, scientists, or medical personnel. Their success depends on everyone doing their part, no matter how small it may seem. But despite all the routines, technology, and support systems, the journey to the center of the galaxy is as much about the inner journey as the outer one. For each crew member, it's a test of endurance, of spirit, and of what it means to be human in the face of the unknown. As the Odyssey journeys deeper into the unknown, the crew begins to witness some of the most incredible sights humanity has ever laid eyes on. Space, in all its beauty and danger, becomes a canvas of discovery, full of celestial wonders that can only be truly appreciated from the heart of the cosmos. Take nebulae, for example, massive clouds of gas and dust where stars are born. They're a sight to behold, vast, swirling and filled with brilliant colors that make you feel like you're flying through an artist's dream. Some of these nebulae stretch across thousands of light years, their gases glowing in shades of red, blue and violet, illuminated by the light of newborn stars. For the crew, it's a daily reminder of the immense beauty that exists beyond Earth. Beyond the nebulae, the crew has encountered other fascinating phenomena, like binary star systems, where two stars orbit each other in an elegant cosmic dance. These systems are some of the most stable in the galaxy, yet their beauty is almost impossible to describe. Watching two suns interact in this way, so far from home, puts everything into perspective. How small, yet how connected, everything truly is. But not all the wonders of space are serene. Some are terrifyingly beautiful, like black holes. These massive objects are so dense that nothing, not even light, can escape their gravitational pull. As the Odyssey passes close to one, the crew can see the light of nearby stars warped, bent, and stretched, as if reality itself is being pulled apart. It's a reminder of just how powerful and mysterious the universe can be, and the dangers that await any ship venturing too close. In addition to the cosmic giants, the crew is also discovering exoplanets, worlds outside our solar system, orbiting distant stars. Some are barren, some might be rich in resources, and some have environments so alien that they challenge everything we thought we knew about life in the universe. These planets are like new frontiers, untouched, and waiting for exploration. The science team is hard at work, analyzing the data, and studying the characteristics of these distant worlds. Could they support life? What makes them unique? Each exoplanet holds clues that could help humanity understand the conditions necessary for life elsewhere, and in some cases, they may hold the answers to questions that have haunted humanity for centuries. Are we truly alone in the universe? Asteroid fields, too, have become a part of their journey. Vast stretches of rock and debris floating in the emptiness of space. While some of these asteroid belts are rich in minerals and resources, others are more treacherous. The Odyssey carefully navigates through them, scanning for potential hazards while the crew keeps a close eye on their surroundings. These fields are a reminder that space is not just beautiful, but filled with hidden dangers. Then there are the cosmic anomalies, gravitational waves that ripple through space, the remnants of long-dead stars. These waves can disrupt even the most advanced technologies, and detecting them requires the ship's sensors to work overtime. But these waves also give us a deeper understanding of how the universe works. They offer clues about the formation of galaxies, the birth and death of stars, and the mysteries of dark matter. The crew of the Odyssey constantly monitors the instruments, gathering data and analyzing the unexpected, each new discovery building on the one before. It's a constant flow of information, a living record of humanity's quest to understand the galaxy. But it's not just the crew's mission to gather data. As they approach the galactic core, the sheer scale and wonder of space forces them to reflect on the bigger picture. Every discovery, every cosmic event, is a reminder of how small and fragile humanity is in the grand scheme of things. Yet here they are, traveling through the very heart of the galaxy, reaching for something no one has ever reached before. While the wonders of deep space are awe-inspiring, the Odyssey's journey is far from easy. For every breathtaking nebula or glowing star, there's a challenge, sometimes more than one, that the crew must overcome. The deeper they go into the galaxy, the more unpredictable the dangers become. One of the biggest challenges the crew faces is cosmic radiation. Space is full of radiation, much more than Earth's protective atmosphere allows. High-energy particles from the sun and distant supernovae bombard the ship every moment. While the Odyssey is equipped with shielding to protect the crew, it's a constant battle against exposure. Crew members take turns in safe zones on the ship, designed to block out as much radiation as possible when solar storms or other radiation bursts hit. But radiation is just one of the many dangers. Deep space is filled with gravitational anomalies, black holes, neutron stars, and rogue planets that can throw the Odyssey off course without warning. The ship's sensors are constantly scanning for these anomalies, alerting the crew if something is detected within a dangerous range. Navigating through these regions requires quick thinking and precision. Even a small miscalculation could send them spiraling into the unknown. Navigating near a black hole, for instance, means dealing with intense gravity that bends light and time itself. The ship must carefully adjust its trajectory, ensuring that it doesn't get too close and risk being pulled into the event horizon, where nothing can escape. The crew knows that in space, the slightest misstep can have catastrophic consequences. And let's not forget about the potential dangers inside the ship. Space is unforgiving, and the crew knows that an emergency can strike at any moment. Whether it's a fire, an equipment failure, or a hull breach, the Odyssey is constantly ready for any crisis. Emergency drills are held regularly. Zero-gravity fire suppression, oxygen system malfunctions, and even decompression events. There's no room for error. The sheer scale of the ship means that maintenance is an ongoing task. There's always something that needs fixing, from the life support systems to the ship's communications array. Parts of the Odyssey are so tight and confined that the crew needs to be nimble, crawling into small spaces and working with tools that might not be available back on Earth. Repairing the ship's vital systems could mean the difference between life and death. Luckily, the Odyssey is equipped with one of the most advanced AI systems in existence, constantly monitoring and rerouting power, adjusting systems to prevent failure. The AI is trained to handle nearly any crisis, and it works hand in hand with the crew, providing real-time data and suggestions to navigate through space's challenges. Then there are the asteroid fields. These massive stretches of rock and debris scatter through space, presenting another type of danger. For the crew of the Odyssey, navigating through asteroid belts requires patience, precision, and a keen understanding of the ship's trajectory. The ship must maneuver carefully, using its advanced sensors to detect even the smallest objects that could potentially cause catastrophic damage. And it's not just about the ship's path. Sometimes the Odyssey has to rely on gravity assists from nearby planets or stars, using their gravitational pull to slingshot the ship forward or change its course. These maneuvers are delicate, requiring the crew to anticipate every twist and turn, adjusting as they go. It's a delicate balance where every decision matters. All these challenges, the radiation, the gravitational anomalies, the maintenance, the asteroid fields, remind the crew just how fragile their journey is. But through it all, they persevere. The Odyssey is a testament to human ingenuity and resilience, designed to withstand the unthinkable and keep pushing forward. Every day is a new challenge, but it's also a new opportunity to learn, to grow, and to adapt. As the Odyssey sails deeper into the galaxy, the crew knows they're entering uncharted territory. The galactic core, a place where the stars are packed tightly together, is unlike any other region of space. The center of the galaxy is a maze of dense star systems, massive black holes, and mysterious cosmic phenomena that scientists have only begun to understand. It's a frontier, a place where the rules of physics are pushed to their limits, and where the unknown looms larger than ever. The first thing you notice when entering the galactic core is the sheer number of stars. Unlike the relative emptiness of the outer regions here, space is crowded. Clusters of stars, each with its own gravitational pull, creating a chaotic, interconnected web of cosmic forces. The ship's navigation systems are working overtime, mapping each star system, calculating their trajectories, and adjusting the Odyssey's path in real time to avoid any unexpected collisions. Every star in the galactic center is a potential hazard. Some are giant, unstable supernovae, others are white dwarfs with incredibly high densities, and in the middle of it all, the supermassive black hole, Sagittarius A*, lurks, its gravitational influence extending far beyond what we can see. The closer you get to the galactic core, the more you realize just how little we really know about it. Scientists have studied the outer regions, but the heart of the galaxy, it's a whole different beast. As the Odyssey moves closer, the stars begin to blur together. It's not just the number of stars that's overwhelming, it's the brightness. These stars shine so brightly that it feels like you're surrounded by thousands of suns. The intensity of their radiation is staggering. The crew must constantly adjust the ship's shielding and ensure that their equipment doesn't get overloaded by the sheer amount of energy pouring out from every direction. Navigating through this star-filled labyrinth isn't just about avoiding collisions. The radiation here is far stronger than anywhere else in the galaxy. For the crew, this means constantly recalibrating their shielding, keeping a careful eye on radiation levels, and ensuring that they remain within safe limits. One wrong move, and the ship's systems could be fried, or worse, they could be exposed to dangerous levels of cosmic radiation. And then there's Sagittarius A*, the supermassive black hole at the very heart of the Milky Way. A cosmic giant with a mass millions of times that of our Sun. Its gravitational pull is so powerful that it distorts space and time itself. Anything that gets too close is swallowed whole. It's a terrifying thought, and yet there's something almost magnetic about it. As the Odyssey draws nearer, the crew can't help but marvel at the sheer size and power of this invisible force. For the crew, approaching the black hole isn't just a scientific mission, it's a moment of existential awe. Here, at the very heart of the galaxy, the mysteries of the universe take on a new meaning. Can we learn more about how galaxies form? Can we uncover the secrets of dark matter and dark energy, the invisible forces that govern the cosmos? Every moment brings them closer to answers, but also deeper into the unknown. But Sagittarius A* isn't the only challenge. As the Odyssey moves deeper into the galactic center, it must navigate through dense star clusters, regions of space where stars are packed so tightly that their gravitational forces begin to interfere with each other. Navigating through these star systems is like maneuvering through a minefield, with each step requiring careful calculation and constant monitoring. It's a delicate dance. One wrong turn could send the Odyssey spiraling into a star or a black hole. The ship's AI is constantly adjusting the course, while the crew works together to make real-time decisions based on the data. It's teamwork at its finest. Every person aboard the Odyssey playing their part to ensure the safety of the ship and the success of the mission. Beyond the stars, there are the nebulae. Vast clouds of gas and dust, remnants of long-dead stars or the birthplaces of new ones. Some of these nebulae are incredibly dense, with electromagnetic fields that can interfere with the ship's systems. Others are beautiful, their colors shifting with the changing light of nearby stars. As the crew passes through these cosmic clouds, they're reminded of how small they are in the grand scheme of things. But perhaps the most difficult part of approaching the galactic core is the unpredictability of what lies ahead. Space here is full of strange and violent phenomena, gravitational waves, intense radiation bursts, and areas where time itself seems to warp. It's a region of space that constantly challenges everything we know, forcing the crew to adapt quickly to new and ever-changing conditions. As the Odyssey approaches the heart of the Milky Way, the crew can't help but feel a mix of excitement and trepidation. After years of travel, millions of miles from Earth, they are on the cusp of reaching the galactic core. It's a place where everything we thought we knew about the universe might change. And yet, as they draw closer, it feels like the final frontier, an unknown, where the mysteries of space, time, and even existence itself come together. The closer the Odyssey gets, the more their sensors pick up strange readings. The sheer concentration of stars, the gravitational forces at play, and the unknown quantities of dark matter and energy make this area unpredictable. Even the most advanced technology can barely begin to process everything in real time. The crew is on high alert, as every sensor sweep, every adjustment is critical in navigating this dangerous region. The core of the galaxy is a place where the fabric of space-time itself is stretched thin. Black holes, neutron stars, and clusters of ancient stars create a gravitational soup that pulls, bends, and warps everything. The Odyssey isn't just fighting against the harsh conditions of space. It's navigating through a dynamic, unstable, cosmic environment that seems to change with every passing second. Scientists aboard the ship are working tirelessly to understand these fluctuations. They're studying the patterns of star systems, mapping out anomalies and doing their best to predict what's coming next. Even though the Odyssey has been equipped with the best possible tools, the galactic core is an area where intuition is just as important as data. The unexpected lurks at every turn, and sometimes, the crew has to rely on experience, improvisation, and sheer will to get through it. And then there are the gravitational waves, ripples through space-time that affect everything. These waves are not just theoretical, they're a real powerful force. When they pass, it's as if the entire universe is shifting. The Odyssey systems detect these waves moments before they hit, but that's often not enough. The ship's course has to be adjusted quickly to avoid being caught in the full force of these cosmic surges. During these moments, teamwork becomes even more critical. The crew has to act fast, each person on the same wavelength, anticipating what's coming, responding to the changes, and ensuring that the ship stays intact. It's an exercise in trust in the ship, trust in the technology, but above all, trust in each other. As the Odyssey moves deeper into the galactic center, they pass through some of the most volatile star systems ever discovered. Stars here aren't like the ones in our solar system. They're older, more unstable, and prone to violent outbursts. Some of them are in their death throes, about to collapse into black holes or supernovae. The crew is constantly on edge, knowing that one wrong turn could bring them into the heart of a stellar explosion. But even with the constant threat of explosions and radiation, there's something almost mesmerizing about these dying stars. Their explosive deaths release bursts of energy and material into the galaxy, seeding new generations of stars and planets. They are the universe's way of renewing itself, a reminder that creation and destruction are two sides of the same cosmic coin. For the crew, these moments are both humbling and inspiring. They are voyaging where no human has ever gone before, watching the birth and death of stars firsthand, experiencing the kind of raw cosmic power that shapes the universe. And yet, even in the face of danger, they can't help but feel a sense of awe. The enormity of what they're witnessing is something no book or computer could ever fully convey. And then there it is. The ultimate mystery. Sagittarius A*, the supermassive black hole at the center of the galaxy. The closer they get, the more the crew feels the weight of its gravitational pull. It's the source of the galaxy's incredible power and chaos, and yet, so much about it remains unknown. What happens at the event horizon? What can we learn from studying this cosmic giant? As they draw closer, these questions become more pressing. The science team is gathering data like never before, analyzing every small change in the surrounding space, every variation in the black hole's gravitational pull. There's a mix of fear and fascination. After all, this is why they're here, at the heart of the galaxy, staring into the abyss, trying to unlock the secrets of one of the universe's most enigmatic forces. The ship's AI is crucial during this phase, calculating the safest course around the black hole, constantly adjusting their path to keep them at the precise distance. But even with all the technology at their disposal, there's an undeniable sense of human curiosity driving this mission forward, the desire to understand, to see the unseeable, and to push the boundaries of what's possible. As the Odyssey passes the black hole, the stars around them begin to stretch into eerie, elongated lines. The ship's systems strain against the warping of space-time. It's a surreal experience, seeing the universe bending and twisting around them, the fabric of reality itself in flux. The crew can feel the pull, but they're safe for now, continuing their journey deeper into the